There we go. Went too far. Okay, so this time, remember the last lesson. Yes. No. I'm busy. No. Okay. Remember, the last lesson was about vertex form, right? Now we do standard form. Standard form is actually the one we were working on all the way up until yesterday for the last class. Then we introduced this vertex form. Standard form is, if I look over here, right, ax squared plus bx plus c. Right, it's the one where you don't have any parentheses. The x squared term is on the left. You've got a linear term in the middle and a constant term on the end. And these are not taken from the SOLs because the SOL doesn't specifically address that. Okay, the standard form. And I think that this is kind of a busy chart. It's the one they have. I think by the end of the lesson, you'll look back on it and say, it could have been maybe made a little clearer. Let's see. The graph of the function f of x equals ax squared plus bx plus c is a parabola. If the a is greater than 0, the parabola opens upward. We already knew that, right? If the a is less than 0, the parabola opens downward. Okay. I'm going to skip a line here. The x-coordinate of the vertex is, all right, now what do we call the x-coordinate of the vertex? What's the letter we use for that? It's h, right? At this point, when they introduce this, they don't use the letter h. They just use the words, the x-coordinate of the vertex. But we know that that's h, right? So we have this thing here gives us a formula for h, which is negative b over 2a. Right, that's the negative b over 2a, but let's just say that is h. We won't call it the x-coordinate of the vertex, just say h equals negative b over 2a. Again, where does the a and the b come from? From the function in standard form, right? It's the coefficient of the x squared and the coefficient of the x, like that. Okay, now, since the h and k are the coordinates, that means the h goes with the k. If you plug in h, you get k. So they're the x and y coordinates that go together at that point. Right, so if you want to know the y coordinate of the vertex, you plug in h into the function. You plug in h here, and you calculate. So the way that they're writing it is, if you look here, right, the vertex, this is a parabola that opens up, and they're saying the vertex is negative b over 2a, otherwise known as h, and the k is f of negative b over 2a, meaning they're taking their h and they're plugging it into the function. Right, so these two are just repeats, except for that this one the parabola opens up, this one the parabola opens down. Okay, so the axis of symmetry, we've already said that's x equals h. Okay, but h equals negative b over 2a. So x equals negative b over 2a, that's the axis of symmetry. Okay, I think we made this point last class. The constant term, that is the y-intercept. The constant term of any function is always the y-intercept, because when you plug in x equals 0, everything else cancels, so the function equals the constant. Or when x is 0, you're on the y-axis. So that's why there's labeled that point, 0c. 0c. Okay, so this is how we sketch the graph of a quadratic function in standard form. And the first thing that we need to know, what's the vertex? Okay, and the first part of the vertex we need to know is, what is the h? Okay, so what is the formula for h? Negative b over 2a. Okay, well, let's look at our function up here. What is the a? What is the b? Okay, so plug those numbers in to this. Right, that will be negative 2 over 2 times negative 2. Right, calculate. What is that? Positive 1/2, right? The negative cancels with a negative, and 2 over 4 is 1/2. Okay, now that we have the h, how do we find the k? you're going to plug in this into x here and calculate. Right? So k equals -2 times 1/2 squared plus 2 times 1/2 minus 5. K equals -2 times 1/4. Okay, 2 times 1/2 is 1 minus 6. So this is -1/2 plus, take that off. 1 minus 6 would have been -5. So that's -5.5. So the HK is positive 1/2, -5.5. There's your vertex. So first, if you're graphing this thing, go over to the graph and let's plot. 1/2 down 1, 2, 3, 4, 5.5. There's the vertex. Okay, does this one open up or down? Yes. Did I make a mistake there? I might have. Okay, let me see. Fix that. Let's see. 2 times, that was -5, and that was 1 minus 5. Okay, mistake. Get rid of that. Get rid of that. Get rid of that. It'll be close, but not the same. Okay, so that was 1 minus 5. Oh, I don't like that. 1 minus 5, which is -4, which makes it -4.5. Okay, thank you. Okay, so now we'll go, oops, gotta erase that. So 1/2 -4.5, so it's more like right there. Okay, so at that point, we should draw in the axis of symmetry. Okay, so let me do that with a nice line. Let me make my line a dashed line. Let me make it red. Let me make it thin. No, I think it needs to be a little more than thin. So here we go. There's the axis of symmetry. Back to the pen. Blue. Okay, now we need to find a point on one side of the parabola, and then we'll use symmetry to find another point. Well, there's one point on this graph that we actually already know by looking at the equation. Which is it? The y-intercept. What's the y-intercept? It's -5, right? So we could take we could take that point right there. That's the y-intercept. So I can come over here and put a point right there on the y-axis. And then if we use symmetry, we know that if there's a point, like there is, 1/2 to the left of the axis of symmetry, then there must be a point which is 1/2 to the right. Just use the symmetry. There's got to be a point right there. And all we're looking for are enough points so you can see the U. Can you see the U with those 3 points? Sure. Is it close enough for government work, as they say? Right. There we go. So when you sketch the graph, when it's in standard form, that's what you do. Find the vertex using the -b/2a, sketch in the axis of symmetry, and then plot another point. A lot of times, the other point will be the y-intercept. Maybe sometimes not, but most of the time it will. I think we did one the other day, which was, it had the vertex was -7, -8, so it was way away from the y-axis, and it opened down. So the y-intercept would have been like so far down there that it's probably not practical. You just pick another point and calculate the y. Right? Okay, so try that. Try to do the same thing on that one. Right? Calculate the vertex, draw the axis of symmetry. In this case, you can definitely use the y-intercept to be one of the points, and that should help you do the other point. how are you doing your h? Negative b over 2a. So where are you calculating your h? Negative b over 2a. I don't see. I mean, everybody should have written down negative b over 2a. Plug it in. I mean, that's the starting point. What is h? Anybody? Did anybody calculate an h? It's negative 3, right? You should have gotten at least that much, right? The h should have been negative 3. And Morgan? So far, so good. Right? So after you get the vertex, then you probably want to say to yourself, is it opening up or down? No. Okay. Looks right. So do we all get to the point where we said h is negative 6 over 2 times 1, right? Which is negative 3. And what was the k? Okay, k you plugged in negative 3 squared plus 6 times negative 3 plus 9, which was 9 minus 18 plus 9, which was 0. Okay, so we've got a vertex. The vertex is negative 3, 0. So that goes on our graph right there. And then we can sketch in an axis of symmetry. 1, 2, 3. That looks about right, like that. And then we need to plot another point. Will the y-intercept work for us this time? I mean, it's plus 9. I mean, I made sure to copy a grid that would include 9 on it. So we go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So that point is on the parabola, right? So what other point is on the parabola? No. Negative 6, 9, right? If there's a point 3 to the right of the axis of symmetry, then there's another point 3 to the left, right? So there's your 3 points that you need to graph. I don't like the way that works, but draw a nice U shape. That's not very good. Yeah. That is terrible. Let's try this again. Okay, so that's one thing. You have one set of homework problems will be just like that. You know, sketch the graph, find the vertex, put the axis symmetry, probably use the y-intercept to be a point, and then use symmetry to make the other point. Okay, the next set of problems is like this. Right? It says, what are the vertex axis of symmetry? Is it a maximum or a minimum value? And then what is the range of the function? Okay, nowhere in there does it say sketch the graph. I mean, I put a grid on here because it would help me to sketch the graph to see what I'm looking at. Okay, and if you don't, then just be right. Okay, let's see. The first thing, let's find our vertex. H equals negative b over 2a. This time there's a negative, the b itself is negative. So it's negative 4 over 2 times negative 3, which is 4 over negative 6, which is negative 2/3. Okay. Find the k. How are we going to find the k? Plug it in, right? I don't like we're dealing with these fractions, but we should be able to deal with fractions. Negative 3 times negative 2/3 squared minus 4 times negative 2/3 plus 6, which is negative 3 times 4/9. Okay, plus 8/3 plus 6. Okay, now this 3 here is going to divide into the denominator of 9, right? That'll make that negative 4/3. So here we go. Negative 4/3 plus 8/3 plus, and just so I've got all the same denominator, I'm going to turn that 6 into, what is it? 3 over 18/3. Okay, now I can add them up all together. That's 26 minus 4, 22/3. And just for the purpose of graphing, 7 1/3. Okay, so I know where the vertex is. It is at negative 2/3, positive 7 1/3. 1, 2, 3, 4, 5, 6, 7 1/3. Okay, does this one open up or down? It's because of the minus, it's going to open down. Okay, now we don't really need to be so precise about the graph. We really weren't asked about the graph. So I'm just going to sketch this in like this, going down, something like that. So that point right there is negative 2/3, 7 1/3. Okay, so there's the vertex. Axis of symmetry, what is it? Yeah, it's that vertical line, so that is x equals negative 2/3. Okay, is that point a maximum or a minimum? It's the highest point, so it's the maximum. That's all you have to say for that. And what is the range of that? The domain is all real numbers. They're always all real numbers for domain, for quadratics. Okay, you see the y goes infinitely down, right? But it stops going up at 7 1/3. So the range is y less than or equal to 7 1/3. Right? You will have y coordinates of the points on that graph that have all the from 7 1/3 down to negative infinity. Yeah. 6. I turn that into a fraction by multiplying by 3 over 3. Okay. Yeah. Okay. Ashley? Right. So try to do the same thing with that one. This one won't come up with fractions. Should be a little easier. Why did that plus become a minus? That right there was plus. Now it's a minus. There you go. Who's got a vertex? What you got, Chris? Your H is good, but your K is not. In fact, even Sandy had H is good, K is not. What'd you say? Wrong. Right. Remember, I've seen the same mistake on all but the last couple, which is, so what did you say was the vertex, the H? Okay, that was the easy part, right? Negative H equals -2 over 2 times -1, which is 1, okay? Then you plug in 1 into this, okay? That minus is in front of the x. You square 1 and get 1, and then you put the minus on it. So it becomes -1 plus 3 plus 2 plus 1, which is 2, not 4. A lot of you have 4 because you're saying, oh, I put the 1 there and then I square -1 and I get a positive, and you get 4, but it's not. That negative is not part of what's being squared, right? Just the x is being squared. K is plug in the H here and here, right? I mean, to tell you the truth, you know the function notation, right? Function notation is f of x. A lot of times in problems like this, in real math, you would just say, there's the h is 1, and now I'm going to find y of 1. It's kind of like combining the y and the f of x into one thing. So y of 1 will be -1 squared plus 2 times 1 plus 1, which is 2. So the point is the vertex is 1, 2, which makes the axis of symmetry, what is it? X equals 1, right? That's the axis of symmetry. Is that a maximum or a minimum point? Okay, this is opening down because of that minus, so it's going to look something like this. Come on. So it's definitely a maximum point. And then what would you say is the range? Y is less than or equal to 2. Okay. Yeah. If it's a minus in front, it goes upside down. If it's a plus, it goes right side up. Right? Yeah. Remember, range means y values, right? Now, up till now, most of the time we talked about domain and range, we had a set of points, and we looked, the domain was all the x coordinates, the range was all the y coordinates. But a graph like this is made up of infinitely many points. You can never write down a list of all the points that make that up. So instead, you're going to have to use inequalities like that to describe the range of values that y can have. So in this case, I mean, the domain is all real numbers because this thing goes infinitely to the left and infinitely to the right, from -infinity to +infinity. All values you can plug in for x. But the highest value of y you can get is the vertex. And then it turns around and goes back the other way. And it's not coming back over here, over here. I mean, that is the shape of the graph. So it's not correct to say that y is all real numbers. Y is actually the highest y value you're ever going to get is 2. And then you'll have values less than that, which is described by that. Okay, y less than or equal to 2. Okay, the next thing is we convert from the standard form to the vertex form, the one we used last time. There's more than one way to do this. We did talk about, in this class, we talked about completing the square. Well, before we talked about quadratic formula, we talked about completing the square as a way to solve quadratic equations, which we don't generally do because that's what the quadratic formula comes from. So we just use the quadratic formula. Even in pre-cal, we're at the point in the book where we have to go from this form to this form, and you can do it by completing the square. Almost nobody does. they all do what we're going to show right here. So we're not teaching completing the square to do this. If you remember, that came in section 4.6, and this is actually section 4.1, so we didn't even get to that point yet. Okay, so notice, here's the standard form, ax squared plus bx plus c. Here's the vertex form, a times x minus h squared plus k. So in order to write the vertex form, we need to know three things. We need to know the h, we need to know the k, and we need to know the a. Well, everything that we've done up till now is finding h and finding k. Right? If you have a quadratic function in standard form, you know the a and you know the b, so you calculate the h and then you plug in the h to find the k. So that's how you're going to find these two values. And then you need to know the a. Well, this a is the same as that a, so you just write it down. Whatever it was in the original standard form, it's the same a here. So you copy it. Right. Here I showed that the h is being calculated there, negative b over 2a. The k is being calculated by putting h in the place of x here and here. A(h squared plus bh plus c. Good. Let me know. Okay. You still copying? Okay, so let's do it. Let's take this standard form of a quadratic function and let's put it into the vertex form. So first I got to calculate the h. H equals negative b over 2a. In this case, that's negative 4 over 2 times negative 1, which is positive 2. Okay. The k is negative 2 squared plus 4 times 2 minus 5, right, which is negative 4 plus 8 minus 5, which is what? Negative 1. Right, so we know our h and we know the k. What is the a? Negative 1, right? The a is negative 1. So here's the standard form. I'm going to use y instead of f of x. It doesn't really matter, but a equals negative x minus 2 squared minus 1. Right? I calculated the h here. That's what goes there. I calculated the k here. That's what goes there. And then I use the same a as we had in that. I use there. Done. Don't forget the 2. Right? It's being squared. I see a lot of forgetting to write that that's squared. What do you think? Does it seem easy or does it seem hard? Josh? Okay. It's the same a as in the standard form. Ax squared plus bx plus c. This one has an a of negative 1. So this one has an a of negative 1. Right? No calculating to do. Just write it. Okay. So try to do the same thing with that. Put it in vertex form. Good job. Both are right. Everything that I've seen so far is right. Everything has been right. You still doing this one? Or did you calculate negative b over 2a? You did it wrong. It's not right. You need to write things down. I'm sure Trevor. Okay, so the formula is x plus 1. Perfect. And I've seen one finished product. Two finished products. Nope. One is, I saw a mistake. There. You got a mistake. So the thing I just said to be careful of. Okay. No? Oh. In this class, no. Yeah. There's a Curtis Brown.
The green one. Is he RBC?
No, I think so. Mark Birdsong?
No.
Or Curtis?
Yeah.
Curtis.
Mm-hmm.
Okay. Okay, so almost everybody I saw was getting the H correct, right? H is negative b over 2a, which is negative 2 over 2 times 1, which is negative 1, right? Now, plug that back in, right? Y of negative 1 is negative 1 squared. Okay, this time the negative will be squared because it's part of the x value, so it will be squared. And that would be plus 2 times negative 1 plus 5. So that is 1 minus 2 plus 5, 4. Okay, so we've got the H, we've got the K. What is the A? A is 1. So here's our 1 times x plus 1 squared plus 4. Or you don't need to write the 1. You don't need to write the A equals 1. Right? Easy? Right? Because what is A in the original? So it's the same. Okay. So one more problem, and then we're done. And this is a word problem, which means you're going to have a word problem in the homework. Okay. So you need to not, especially in a class like this, not freak out when you see a word problem. I mean, if you're not going to read word problems, then there's really no point being in this class or going on to pre-cal or doing anything like that. I mean, don't raise your hand and say you're going to Virginia Tech to be an engineer if you don't even read word problems. Okay? Engineers read word problems. What you see is most of these word problems in a particular section, there's a lot of words in front, but in the end, you're doing the thing you were doing anyways before it was wrapped around some words in a word problem. So let's see. And the Zhao Bridge in China is the oldest known arch bridge, dating back to AD 605. You can model the support arch with the function, and notice that the function is a quadratic function, right? It's a quadratic that opens down because of the minus. Okay, what's the y-intercept? It's 0. There is no constant term, so it's actually 0. Okay, they want to know how high is the arch above its supports. So I graphed it in the calculator, and that's what this graph is right here. You can see there's the y-intercept is 0. It's a quadratic function that opens down, as we already said, and we're trying to find the highest point, which is a maximum. But the maximum is the vertex. So actually, all they're asking for when they ask for the how high is the maximum, which means vertex. say, how do we calculate the vertex? Negative b over 2a. So h will be negative b over 2a, and even if the numbers are kind of funny, it's still the same math, right? Negative 0.131148 divided by 2 times negative 0.001075. So put that in the calculator and let's see what the x-coordinate, right? The h is that value right there. It's the x-coordinate of the maximum or the vertex. I don't know if I still have that in there. I think I do. If you're trying it, it should be 60.999. How about let's just call it 61, right? 61. So that is the h coordinate right there. But they want to know how high is it, right? So we need to find the k. We need to know the y value. So how do you find the y value? Plug it in into that equation. I mean, you could put that value. You could put in 61 as we rounded it off. What I like to do is this. You know, I would set my calculator, second table set, to ask. Right? Go down above the window. It says table set. So go second table set or second window and set your independent variable or the x to ask. And then when you go to the table, you can just enter the x value you want and it'll tell you the y value. Second window, right? Second window, right? And so set on, this is the x coordinate. Set it to ask so that when you go to the table, you could put in the x value that you want, right? If you don't do that, there's other ways to find that. I mean, you could just plug it in and see what you get. Yes. Yes. What you need. Who's that? That's not in my class. No. Oh no, okay, I know. It is. The way you pronounce it, I know, I got it. Okay, I got it. Okay. She's an early dismissal. They mangled your name, so I was like, well, I never heard of that one. So anyways, you should have gotten the value of 4. The height of this thing is 4, which means as you look at it here, it's not really in proportion because it's 61 feet to here, which makes it 120 feet all the way across, and it's only 4 feet high. So our bridge is really more like, you know, something like that. It's not a very high bridge. But again, it was built in 600 AD. So in the end, you know, if that had not been wrapped in the words of a word problem and you were asked to find the maximum point, that means find the vertex, negative b over 2a, right? Okay. So that's what we did. We graphed them. We identified a vertex, axis, symmetry, and range. We understand that the vertex is the maximum or the minimum. We converted from standard to vertex form, and then we solved real-life problems. And that's the homework. So if you want to write that down, and we will get started on a quiz.